Question 9. It only has one part, 9.1. And then section B, the multiple choice questions, which I will not include in the playlist. I'll probably, if I do go through the multiple choice questions, I'll probably create a separate playlist and then just go through each individual one, or just go through, each individual one makes sense. And then the ones that I find difficult, or the ones that are difficult to most students, I'll create in a separate playlist. But anyway, question 9. A student was given a powder made from a mixture of anhydrous barium chloride and anhydrous magnesium chloride. The student dissolved 1.056 grams of the powder in water in a conical flask and added an excess of sulfuric acid. A white precipitate formed and was filtered off, washed and dried. The mass of the solid was 0.764 grams. Identify the white precipitate and calculate the percentage by mass of magnesium chloride in the powder. So, a lot of information. Full paragraph almost. Pretty much full paragraph. And then it says, identify the white precipitate and calculate percentage by mass. Like it's that simple. So the white precipitate, is going to be BaSO4, barium sulfate. Now that is a very key thing. Once we work that out, the rest of the question becomes slightly more easier. So now we can find out the moles of barium sulfate. So the moles of BaSO4, because now we know the MR of BaSO4, the mass of BaSO4, well, we know the mass of the solid was 0.764. Divided by the MR, well, all we need to do is go to the periodic table. BA, let's find BA. Where is that? BA, still can't find it. It's probably right in front of me, isn't it? BA, there it is. So 137.3 plus what is it? 137.3 plus SO4, so plus S 32.1 plus O4 16 times by 4, which is plus 64. So I'll get 0.764, the mass, divided by, let's add up the MR, 137.3 plus 32.1 plus 64, 233.4. And now we can find out the moles. 0.764 divided by 233.4, 3.27 times by 10 to the power minus 3, 3.27 times by 10 to the power minus 3. And that's the moles of barium sulfate. Therefore, the mass of barium chloride, well, we know the moles of barium chloride is going to be the exact same thing. It's a 1-to-1 molar ratio. So the mass of barium chloride, BaCl2, well, moles is mass over ml, mass is moles, 3.27 times by 10 to the power minus 3 times by the ml times by ml BaCl2 Ba 137.3 plus 35.5 times by 2, so 137.3 plus 35.5 plus 35.5, and we get the mass as 3.27 times by 10 to the power minus 3 times by 137.3 plus 35.5 plus 35.5, and I get 0.681. 0.68 18 grams, 1 grams, And now the final thing, to calculate percentage by mass of magnesium chloride, is going to be the mass of magnesium chloride. Well, this is the mass of barium chloride, so find the mass of magnesium chloride. It's just going to be 1.056 grams minus this. That'll give me, so percentage by mass is going to be 1.056 total mass minus 0.681, which will give you the mass of magnesium chloride, divided by total mass, 1.056. Percentage, yeah, it says percentage by mass, so we times by 100. 1.056 minus 0.681 over 1.056 times by 100, and I get 35.5%. 35.5%. And that is the end of question 9. It's just one part. That's why I usually generally scroll up, but it's just one part in this case. And that's the end of question 9.